Good morning all. Today we'll see a lecture on DIT FFT algorithm for 8-point FFT. Now, as I have told you earlier, for DIT FFT algorithm, the input sequence is in bit reversal order and the output sequence is in natural order. While for DIF FFT algorithm, the input sequence is in natural order and the output sequence is in bit reversal order. Now I have also told you that it is 8-point DFT, so we are seeing radix 2 FFT algorithm. So radix 2 means what? Its base is of 2. If the capital N is equals to 8, so it can be represented as 2 raised to 3 because it is radix 2 algorithm, 2 raised to 3. That means 3 will be your max stages. Number of stages you will have for this FFT algorithm is 3. So this is my first stage, second stage and third stage. We have seen in the summary of DIT FFT algorithm. So 3 stages will be having, and as you see here the input sequence is in bit reversal order. So first we'll be having the even and then we'll be having the odd part. Okay, odd samples, you can say. Even samples first we'll have and then we'll be having the odd samples. So as we have a 3 stage, and also we have seen in each stage will be having n by 2 butterflies. Each stage consists of n by 2 butterflies. So here also we'll be having 4 butterflies, 1 2 3 4. Here also we'll be having 1 2 3 4 butterflies. Here also we'll be having the 4 butterflies. Now the each butterfly is input and output samples of each butterfly is separated by, here it is separated by 1 samples, here also it is separated by 1 samples, here also it is separated by 1 samples, here also it is separated by 1 samples. We have seen here it is separated by 2 samples and here it is separated by 4 samples. Now sets or sections will be having, so here we'll be having sets as a 4, here also we'll be having sets as a 4. Sorry, here we'll be having set as a 4, here we'll be having set as a 2, and here we'll be having set as a 1. That means this particular flow graph is repeating for what time? That much number of sets will be having. Here this set is repeating only for one time and this set is repeating only for one time. After completing each butterfly, we need to multiply with the -1 sign. Already here we have multiplied with the -1 sign, and the Twiddle factor. For completing each butterfly, we have to multiply with the Twiddle factor exponent. So here Twiddle factor exponent is W80. Here also W80, W80 and W80. In last lecture, previous lecture, we have seen for how much time these Twiddle factor exponents are going to repeat. So for stage 1, for DIT FFT algorithm for n is equals to 8 points. So here it is repeating for 4 times. This Twiddle factor exponents is repeating for 2 times and these Twiddle factor exponents are repeating for 1 times. So in this we have seen in the summary of DIT FFT algorithm. So in this case we have to draw, in this way we have to draw a flow graph of DIT FFT algorithm for 8 point. So here the input sequence is in bit reversal order and the output sequence is in natural order. Now one basic difference in between DIT and DIF FFT algorithm is after addition. See, after this point we are multiplying the Twiddle factor exponents. Okay, after addition here we are multiplying the Twiddle factor exponents. See here Twiddle factor exponents are multiplying before the addition. In DIT FFT algorithm, Twiddle factor exponents are multiplying before the addition. You can see here Twiddle factor exponent is there. Here also, here it is multiplying before addition, and here also it is before addition. So that is the second difference of DIT and DIF, that Twiddle factor exponents are multiplying before addition, and in DIF Twiddle factor exponents are multiplying after addition. So these two basic difference between DIT and DIF FFT algorithm. First difference is what? The input sequence is in bit reversal order and the output sequence is in natural order for DIT FFT algorithm, and the input sequence is in natural order and the output sequence is in bit reversal order for DIF FFT algorithm. Now in DIT FFT algorithm, the twiddle factor exponents are multiplying before addition, and in DIF FFT algorithm the twiddle factor exponents are multiplying after addition. Okay, in DIT it is before and in DIF it is after addition. Okay, so we'll see a question on DIT FFT algorithm, or you can see first we'll be seeing the how to calculate the value. Now here we'll be having, so for 8 point we have to calculate the value. We have to calculate this value W80 we need to calculate, because for multiplication is required W81, W82 and W83. So how to calculate this value? See this carefully. W81 you can write like this. W81 is equals to what? Is equals to e raised to minus j 2 pi by n. So value of n is equals to 8 here, and the exponent is what? Exponent is 1. So here it is going to multiply with 1. So Wn or W8, it is known as what? It is known as twiddle factor. This value is known as twiddle factor, and 1 is what? 1 is known as twiddle factor exponent. This one is known as what? This one is known as twiddle factor exponents. Now we'll be having e raised to minus j 2 pi by 8. So we can write it as e raised to minus j pi by 4. So e raised to minus j pi by 4, we can write it as cos pi by 4 minus j sin pi by 4. In Calc you take a mode as a complex and you convert a degree into the radian. So directly you can put cos pi by 4 minus sin pi by 4 into j. So directly we'll be getting the value. Okay, in similar way we can find the value of W82 and W83. This value is required for the calculation. Now see here, if I am considering this is the output of stage 1, so stage 1 output I can write it as x of 0 plus W80, that value is always equals to 1. So here you consider or you not, it will remain the same. So x of 0 plus x of 4, this is the value of s of 0, or you can say s1 of 0. Here s1 of 1 you can write x of 0 minus x of 4. Similarly here x of 2 plus x of 6. At this point it is x of 2 minus x of 6. At this point it is x of 1 plus x of 5. At this point it is x of 1 minus x of 5. At this point it is x of 3 plus x of 7. At this point it is x of 3 minus x of 7. So this is the output of stage 1. And here as stage 2, this value is what? S of 0. Here this value is what? S1 of 0. And here the value is S1 of 2 multiply with W80. So in this way we have to calculate for stage 2 also and for stage 3 also. After this we will be having this as the output of stage 1. Okay, I have told you earlier, here you consider W80 or you not, it will remain the same, that value is equals to 1. Now this is the output of stage 2. So S2 of 0, as we can see here, S2 of 0 will be S1 of 0 plus W80 S1 of 2. S2 of 1 is equals to S1 of 1 plus W82 S1 of 3. You can see here S2 of 1 in the graph also. And this is the last output of stage 3. So this is the last, this is the FFT, this is the FFT, this is the answer, required answer for your the given signal x of n. So in this way we can find 8-point FFT using DIT algorithm. Now we'll see some questions regarding DIT FFT algorithm, so it will be more clear to you. So now the question is what? Compute 8-point DFT of a given sequence using radix 2 DIT FFT algorithm, and the sequence of x of n is given like this: 1 by 2, 1 by 2. Initial 4 samples are 1 by 2 and the 4 samples are 0. Now, so first we have to draw the flow. So this is the flow graph for 8-point DIT FFT algorithm. So as I have told you that input sequence is in bit reversal order and the output sequence is in natural order. So first we have to find the stage 1 output, and before stage 1 output we require some value W0, W1, W2 and W3. So this value will be getting W0, the value is always equals to 1, W81, so I have told you this value is e raised to minus j pi by 4. So after putting cos pi by 4 minus j sin by 4, will be getting this value W82 and W83. So first step is what? We need to find the output of stage 1. So this is the output of stage 1. As you can see here, S1 of 0. So this point is S1 of 0. S1 of 0 is the addition of x of 0 plus x of 4. So x of 0 plus x of 4, W80, that is the Twiddle factor exponents, and that value is equals to 1. So 1 by 2 plus 1 into 0, it becomes 1 by 2. S1 of 1, so x of 0 minus x of 4, x of 0 minus x of 4, so 1 by 2 minus 1 into 0, so it becomes 1 by 2 only. This value S1 of 2 is the value of x of 2 plus x of 6. This value is x of 2 minus x of 6. This value is equals to x of 1 plus x of 5. This value is equals to x of 1 minus x of 5. This value is equals to x of 3 plus x of 7, and this value is equals to x of 3 minus x of 7. So in this way we can calculate the stage 1 output, and we have got the output of stage 1. So all the values are 1 by 2 here. Now in similar way we have to find the output of stage 2. So for stage 2, so just simply we need to put the value of S1 of 0. S of 2 is equals to S1 of 0 plus W80 S1 of 2. So 1 by 2 plus 1 by 2, so it becomes 1. S2 of 1 is equals to S1 of 1 plus W82 S1 of 3. I will show you here. See here, this is the value of S1 of 0. So it is the addition of S1 of 0, that is the output of stage 1. S1 of 0 plus S1 of 2, W80 is equals to 1. Now here it is S1 of 1 plus S1 of 3, W82. At this it is S1 of 0 minus W80 S1 of 2, and at this it is S1 of 1 minus W82 S1 of 3. In similar way we can find the another value also in the way. S2 of 4 is equals to S1 of 4 plus W80 S1 of 6, S2 of 5, S2 of 6 and S2 of 7. This is the output of stage 2. Okay. Now after having the output of stage 2, we will be having the last stage, that is the stage 3. So in the stage 3 here we will be getting the discrete frequency sequence. So x of 0 is equals to S2 of 0 plus W80 S2 of 4, as you can see here. So x of 0 is the addition of S2 of 0 plus S2 of 4. Then x of 1 is the addition of S1 of 1, S2 of 1 plus W81 S2 of 5. Now x of 2 is the addition of S2 of 2 plus W82 S2 of 6, and S3 x of 3 is equals to S2 of 3 plus W83 S2 of 7. In similar way we can find x of 4 also, x of 5, x of 6 and x of 7. So we will be getting the output of stage 3 here. So we have got the x of 0 as 2, x of 1 as 1 by 2 minus j 1.207, x of 2 is 0, x of 3 we got, x of 4 we have got, x of 5, just simply you put the value and do the calculation, x of 6 and x of 7. So after this discrete frequency sequence we have to write the sequence. So x of k is equals to, we have got the x of k, and how we are going to verify? Summation of x of k, we have to verify like this: summation of x of k divided by capital N is equals to x of 0. Okay, so value of x of 0 is 1 by 2. Now if you add this, so see here, so here imaginary part minus j 1.270 and plus j 1. So these are getting cancelled. So here these are getting cancelled here. Okay, minus j 2.207 plus j getting cancelled. So 1 by 2 plus 1 by 2, it becomes 1. 1 by 2 plus 1 by 2, again it becomes 1. So 2 plus 2, it becomes 4. So 4 divided by capital N is equals to 8. So that answer is equals to 1 by 2. So the value of x of 0 in the sequence of x of n is equals to the 1 by 2 only. So the answer is correct. In this way we can find the DIT FFT algorithm for 8 point. Now you can find the next also. So for a given 8 point DFT sequence, now here it is given x of n is equals to 1 for 0 to 3 and for 4 to 7 this value is equals to 0. So now what is the sequence of x of n? So the sequence of x of n is equals to 1, that is valid for 0, 1, 2, 3, and it is 0 for 4, 6, 7, 4, 5, 6, 7. So this will be the equation of x of n. At 0 it is 1, at 1 it is 1, at 2 it is 1, at 3 it is 1, at 4 it is 0, 5 it is 0, 6 it is 0, and 7 it is 0. And you do the same method, will be getting the answer of x of k as this. Okay, so you need to solve this. So after this we'll be seeing the DIF FFT algorithm for 8 point. So I have told you earlier, so DIT and DIF, so DIF is the mirror image of DIT or DIT is the mirror image of DIF. Okay, so this is the flow for 8 point DIF FFT algorithm. So I have told you earlier, so here input sequence is in natural order and the output sequence is in bit reversal order. So here we can say it is bit reversal order. Now also I have told you that here the Twiddle factor exponents are multiplying after addition. Here also it is going to multiply the after addition. Here also it is going to multiply after addition. And in DIT it is before addition it is going to multiply. Now as you can see the structure, it is the mirror image of DIT FFT algorithm. So in the similar way we have to find, and the number of stage I have told you that for capital N is equals to 8. So number of stage are nothing but 3. So 2 raised to 3. So 3 will be the maximum stage. You can say that it is the stage 1, stage 2 and stage 3. Twiddle factor exponents we have calculated here. After completing each butterfly we need to multiply with Twiddle factor exponents, and to the butterfly we have to multiply with the -1. So we'll see how to calculate the stage 1. So here you consider it is S1 of 0. So S1 of 0 is the addition of x of 0 plus x of 4. S1 of 1 is the addition of x of 1 plus x of 5. Here it is the addition of x of 2 plus x of 6. Here it is addition of x of 3 plus x of 7. Now here it is addition of x of 0 minus x of 4. Then we need to multiply W80. Here it is addition of x of 1 minus x of 5. Then it is going to multiply with W81. And here it is the multiplication of x of 2. Sorry, here it is the addition of x of 2 minus x of 6. Then it is going to multiply with W82. At this stage it is the addition of x of 3 minus x of 7. Then it is going to multiply with W83. So this value already we required. This value we require for Twiddle factor exponents, that is going to multiply with the summation. So as you can see, this is the output of stage 1. I have told you after addition we need to multiply the Twiddle factor exponents. So here, so in bracket the term is there. So after that we need to multiply the Twiddle factor exponent. So this is the output of stage 1. Next we have to find the output of stage 2, and the last one is output of stage 3. but here we need to remember that the output of stage 3 it is in bit reversal order. So we have to see this very carefully. So while writing the sequence of x of k, first we have to write it is x of 0, then x of 1, then x of 2, then x of 3, 4, 5, 6, 7, in this way. But actually we are getting output is in what? We are getting output is in bit reversal order. So here we have to be very careful while calculating the discrete frequency sequence. So here we have got the output of stage 1 also, output of stage 2 also, and output of stage 3 also. So as you can see here after addition Tweedle factor exponent is going to multiply. As you can see here, after addition, after addition, after addition, and after addition, here we have not multiply. Why? Because W80, that value is always equals to 1. That's why I have not multiply here at this stage 3. Now we'll see a question regarding DIF FFT algorithm. So I have taken the same questions, and when you calculate the answer using DIT or DIF, we'll get the same answer. So this is the flow for 8-point DIF FFT algorithm. So these Tweedle factor exponents we require while calculation. Now we are going to find output of stage 1. So as this stage 1 output is equals to what? Here S1 of 0 is the addition of x of 0 plus x of 4. S1 of 1 is the addition of x of 1 plus x of 5. S1 of 2 is the addition of x of 2 plus x of 6. S1 of 3 is the addition of x of 3 plus x of 7. At this point S1 of 4 is the addition of x of 0 minus x of 4, then it is going to multiply with W80. X1 of 5, S1 of 5 is the addition of x of 1 minus x of 5, then it is going to multiply with W81. Similarly we can find S1 of 6 and S1 of 7. So here also Tweedle factor exponent is what? W82, and here it is W83. So we will be getting the output of stage 1. Also here we have to find the output of stage 2. So here S2 of 0 is the addition of S1 of 0 plus S1 of 2. Here S2 of 1 is the addition of S1 of 1 plus S1 of 3, and here S2 of 2 is the addition of S1 of 0 minus S1 of 0 minus S1 of 2, then we need to multiply with W80. Here it is the addition of S1 of 1 minus S1 of 3, then it is going to multiply with W82. In this case, in this way we can find the output of stage 2. So for S24 also, for S25 also, for S26 also, for S27 also. So we will be getting the output of stage 2. Similarly we have to find the output of stage 3. So in the output of stage 3 we will be getting, it is not, I have told you earlier, it is in bit reversal order. So while writing the sequence of x of k, we have to be very careful. So initially we need to take the sequence of x of 0 I have taken here, then x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, and x of 7. So as you see here, this is the same answer that we have got in DIT FFT algorithm. So summation of x of k divided by capital N is equals to the first x of 0. So here also we will be getting the same value as 1 by 2. You add the summation of x of k divided by capital N, you will be getting 1 by 2 also. So in this way we can calculate the DIT FFT algorithm for 8 point. The procedure it will remain same for 2 point, 4 point, 8 point, 16 point, and so on. Just we need to first draw the flow, then you can do the calculation. So thank you very much.